Alright, let's finish up the notes from Friday, September the 20th. And we finished up with example 3, or we left off with example 3. And here they've got a graph that appears to have some interesting things going on. And the first thing I want to look at is the fact that the function value is positive anywhere above the x-axis. So the function itself is positive in this area right here. The function value is positive here. And then the function value is negative down here in this area here, and negative down here as well. So let's make that distinction that the function value being positive and negative doesn't necessarily have anything to do with the slope of this curve. So let's take a look at the derivatives, and let's look at the slope of the tangent line. So here we can see that at this very beginning it's very, very, very steep, but it's a negative slope. So it has a negative slope, continues to be negative, all the way down the curve, and it's starting to flatten out a little bit. And then when we get to this spot right here, where x is negative 1, 2, 3, 4, whatever that is, negative 5, we have a derivative of 0 there because we have a horizontal tangent line. And then at that spot, this curve starts to become positive, remains positive all the way up, remains positive until it flattens out again at this spot, and then the function starts decreasing. And so when it's decreasing, it becomes negative, negative, negative. Okay. So it's generally a good idea to identify those points, and here they want us to label directly on the graph the points described below. So the first point needs to have a negative derivative and a negative function value. So where is the derivative negative? It's negative here, but the function value at this point is positive. So we need to go over here and looks like label this one A. The second one is where B has a positive function value and a negative derivative. So a positive function value would be, trying to find the highlighter. Well, that's not working very well. Let's see if we can scoot this over. That just goes more that way. Huh. Oh, I got it. Sorry about that. Technical difficulties. Point B has a positive function value and a negative derivative. So positive function value is anything above the x-axis, and here we have a negative derivative. So we're going to call this point B. And then part C says the slope of the tangent line at the point C is 0 and the function value is negative. Well, this one has a derivative of 0, but its function value is below the x-axis, so that's point C. Point D has a positive derivative. Well, it has to be this one, because the only other point has a 0. Point E is a maximum point in its own little neighborhood and has a positive function value. So we'll learn about this, that this is called a relative maximum. It's not the absolute maximum point on the graph, as you can see. It's a lot taller over here, but in its own little neighborhood, like it's described here, that's known as a local max. Okay, let's take a look at the next page. The next page has example number 4, says given that the top graph is the derivative, so this first one is the derivative, they want us to sketch a possible original function f on the bottom graph. So let me slide this down a little bit so you can see a little bit. And let's see if I can move this whole thing down a little bit. Now I'll just scoot this one over. There we go. So let's identify a couple of the some of the interesting points. Well, here the derivative is 0. The derivative is 0 here. The derivative is 0 here because it crosses the x-axis, and it's 0 there. So anytime we have a 0, it's going to indicate that we either have a point where the graph is increasing to the left and then decreasing to the right, or it could be the opposite, right? It could be a decreasing function with a negative slope and the 0 right there, and then on the right hand side of that the function is increasing. So let's highlight this. Here we have our horizontal tangent, or the slope is equal to 0, and that indicates that this first one is a relative maximum, and down here we have a relative minimum. So let's examine this first leg of this graph, and we see that this function is decreasing, decreasing, decreasing. Alright, it's decreasing. Well, actually, let's think about that for a second. Here, the derivative has a positive slope, right? Positive slope. Down here, the derivative is a negative slope. Still negative here. The derivative has a positive slope and a positive slope and a positive slope until we get past here, and then it changes back to having a negative slope, and a negative slope. So let's see which one of these situations describes, as we move from left to right, a positive slope, a 0, and then it turns to negative. Well, it's this scenario here where we have a relative maximum, and this is a relative minimum down here. So a relative maximum might be something like this. And right there, at this point, we need to indicate that that is changing directions. Well, immediately after that, we have a negative derivative, which means I'm decreasing, and then it's going to stay negative in this region here. This entire region is negative, so that means I have a negative slope until I get back and reach this 0 spot where it changes from decreasing back to increasing. So perhaps it looks something like this, and then I'm increasing until I get to what? Back to this point. So at that spot, it goes from increasing to decreasing, and then the function continues on this way. So this is just one possible graph. Yours might be higher or lower than this, but anyway, this should take care of it. Alright, let's take a look at example number 5. Try to drag this over here a little bit. It says that identify the requested intervals for the function shown here. So let's read what they say. They want to know the intervals where you have a negative derivative. And this is the function. So that's the most important thing, is to realize that you're looking at the function and not the derivative here. So let's just identify where would this have a derivative that would be negative. Well, the derivative is just the slope. The derivative is just the slope. So we just need to look for the tangent lines. So this portion here, we have negative tangent lines all the way down here. And then we get a spot here where we have a horizontal tangent. So the derivative itself would be changing from negative in yellow, and then it's horizontal at that orange spot, and then it becomes a positive slope all the way up to this spot. And then we have a 0, and then it changes back to negative as we progress on, and then we have another 0 spot, and then we go to increasing again, which is increasing all the way over here. Alright, so let's label that. We have a negative derivative, we have a derivative of 0 here, and then it turns to positive in this pink region. We have a derivative of 0, a small portion of negative, and the slope of the tangent line here is 0 again, and then it's increasing or positive here. So where are the integrals where the derivative is negative? Okay, it looks like it starts off that this function continues in this fashion forever, so we're going to call that negative infinity. And where does it change directions, basically? It changes directions here when x is, looks like about a negative 1, 2, 3. That's a negative 3. Okay. And it's also negative, looks like between 1, 2, this is positive 3, and it goes to 4, 5, and 6. Now, notice that this is the open bracket notation. It's not closed here because it doesn't actually include 6. In fact, that's 6 that's equal to 0, right? And the same thing here at negative 3, the slope hit 0, so we're not using the squared off brackets to indicate that. Okay, so where are the intervals where the function decreases? Well, the function itself is decreasing where this derivative is negative, right? So part B is exactly the same answer that you got for A. It's decreasing on these intervals here. So the function is decreasing when the slope is negative. And so what are the intervals of the positive derivative? Well, that's where it's highlighted in pink. So it looks like it goes from what? From negative 3 up to positive 3 in this region here. And it's also increasing. Looks like that turns at 6, right? And then it continues on to positive infinity. So just like in part B, where the function was decreasing based on the derivatives, the same thing is true on D. So between negative 3 and 3, and between 6 and infinity, it's increasing. So let's finish up and make a few observations. And it says that, so notice from example 5 that intervals of negative derivatives corresponds to intervals of negative slope. The derivative is the slope of the tangent, and it also tells us where the function is decreasing. So the counter to that is when you have an interval of positive derivative, it indicates a positive slope, and it indicates where the function itself is increasing. Okay, I think that about wraps it up for the note section, and I will put a look at some of the homework problems and kind of give you some guidance on that, some hints where to get started. Okay.